All right, so now we're moving on to the non-homogeneous second order differential equation. Now, a non-homogeneous second order differential equation is of the form a d2y by dx squared plus b dy by dx plus cy is equal to f, where f of x, is equal to f of x, where f of x is not 0. We look at equations where we are going to look at equations where f of x is I, a polynomial in x of at most degree 2, a trigonometric function, and exponential function. Now, how do they go about coming up with, how do we go about solving a differential equation of this form? So here's what they said. What they did is that they said, let h of x be a solution. So h of x is a solution, and g of x be a solution of a d2y by dx squared plus b dy by dx plus cy is equal to 0. In other words, h of x is the solution, but g of x is the solution of the homogeneous part of the differential equation. H of x is the overall solution, and g of x is the solution of the homogeneous part. So they said let y is equal to h of x, dy by dx is the first differential of x, d2y by dx squared the second differential of x. So therefore a plus h double prime of x plus b h prime of x plus ch of x is equal to f of x. Then, as they said before, remember that g of x is the solution of the the homogeneous part of the differential equation. Then let's say let y is equal to g of x, dy by dx is the first differential of the g of x, d2y by dx squared is g double prime of x. So a g double prime plus b g prime plus c g of x is equal to 0. Now remember that h of x is the solution. H of x, y is equal to h of x is the solution of a d2y by dx squared plus b dy by dx plus cy is equal to f of x, and that y is equal to g of x, sorry, not f of x, y is equal to g of x is the solution of the homogeneous part. The homogeneous part of the differential equation is a d2y by dx squared plus dy by dx plus cy is equal to 0. So what that means is that if I add a h double prime of x, sorry, if I add 1 and 2, let's look exactly at what is 1 and what is 2. This is 0. If I add 1 and 2, here is 1. And 2, here is 2. If I add 1 and 2, essentially what they're saying is that I would still have a solution. If I had 1 and 2, and I would still have a solution. The reason I would still have my solution is, you would get the solution, is that 1 is equal to f of x and 2 is equal to 0. So if I add 1 and 2, essentially I still have 1 because 2 is equal to 0. Now, since 1 is a solution, and when I add 2, it really doesn't change it because 2 is equal to 0. And when you add 0 to something, it doesn't change it. That y is equal to h of x plus g of x is a solution of the differential equation. Now, g of x is called the complementary function. All right, and I'm guessing it's called complementary because it was the solution from g of x was equal to 0, so it really doesn't change it. It's complementary. And h of x is called the particular integral pi. I know you might not understand what this is saying, but as we progress, you'll get it fully. So therefore, the solution of my differential equation of the second order on non-homogeneous differential equation is y is equal to cf plus pi, where cf is the complementary function and pi is the differential equation. So to find cf, we solve a d2y by dx squared plus b dy by dx plus c y is equal to 0. The pi depends on f of x. We will consider 3 cases for the pi. A, when f of x is a polynomial, B, when f of x is a trigonometric function, and C, when f of x is an exponential function. So we're going to start at example 15, where we're going to look at when f of x is a polynomial or polynomial of degree n. In this case, the particular integral is also a polynomial of degree n. All right, so let's have a look at example 15. Example 15 says solve the differential equation d2y by dx squared minus 6dy by dx plus 9 9y is equal to 4x plus 1. Now this is a non-homogeneous second order differential equation. It is of the form A d2y by dx squared minus b dy by dx plus cy is equal to f of x. Now, to solve this equation, or the solution for this equation is equal to y is equal to cf plus pi. Cf is called the complementary function. Pi is called the particular integral. Now, let's first find CF. To find CF, we need to solve the homogeneous part of the differential equation. d2y by dx squared minus 6 dy by dx plus 9y is equal to 0. As you all know, to solve this part of the equation, we need to form the AQE, which is the auxiliary quadratic equation. It would be m squared minus 6m plus 9 is equal to 0. Now, where did I get my coefficients for the auxiliary quadratic equation? The coefficient for the coefficient of m squared is the coefficient of d2y by dx squared. The coefficient of dy by dx is the coefficient for m, and c is the coefficient of y. Now, if I factorize this, I'm going to end up with m 3, 3, minus, minus is equal to 0. So m minus 3 would be equal to 0. M would be equal to 3 twice. Now, since m is equal to 3, the solution, or the CF, would be y is equal to ax plus b e to the 3x. So this form of the solution of the homogeneous differential equation, this form is when the solutions are real but equal. Now let's go out to the particular integral. Now for the particular integral, the solution, or the particular integral, the solution is y is equal to, let us say ax plus b. In other words, the solution is of the same form as f of x. F of x is a linear expression, 4x plus 1, and the solution is also a linear expression, ax plus b. Let's differentiate. Dy by dx is equal to a, and d2y by dx squared is equal to 0. So remember, you going back now to the equation, dy by dx minus 6dy by dx plus 9, we get, all right, let me just write that. Going back to this solution, we can say that 0, which is what dy by dx is equal to, minus 6 dy by dx, which is a, plus 9 y, which is ax plus b, is equal to f of x, which is 4x plus 1. And our objective is to determine the value of a and b. So this becomes 6a plus 9ax plus 9b is equal to 4x plus 1. Then we have 9ax plus 9b minus 6a is equal to 4x plus 1. Next, I can say 9a is equal to 4, and this is the x coefficient. Therefore, a is equal to 4 over 9. All right, let us now find b and complete the solution of this question. For b, we can say that 9b minus 6a is equal to 1. That is the constant. So 9b minus 6a is equal to 1. 9b minus 6a is equal to 1. This is 9 times b minus 6 times a. A is 4 over 9 is equal to 1. 3 into this is 2. 3 into this is 3. We have 9b minus 8 over 3 is equal to 1. 9b is equal to 1 plus 8 over 3. 9b is equal to 11 over 3. Divide both sides by 9 and we get b is equal to 11 over 27. So now that we have a is equal to b, our solution is y is equal to cf plus pi. Our solution is y is equal to a x plus b e to the 3x plus y. Y is what? Ax plus b, and a is 4 over 9. So it's 4 over 9x plus b, which is 11 over 27. Now, y is equal to ax plus b, multiply by e to the 3x plus 4 over 9x plus 11 over 27 is my solution to the differential equation.